call that. So, I mean, we had this inequality. This was coming because Fn is converging to F uniformly, and so also pointwise. And then this was second one was basically using the continuity of that Fn. What was the third inequality? Can you remind, if you remember? Epsilon 3, we had some third inequality. So maybe that could be the uniform this inequality, right? For all n bigger than n naught. I mean, yeah, if we need that. I mean, it subsumes the first one, but yeah. And then what did we need to prove? We wanted to prove that f is continuous, right? So we wanted to prove that f of x minus f of x naught is less than epsilon. This is what we want to show.
Yeah.
Okay. If I'm missing some inequality, you can tell me.
No, this.
Yeah. Or we would
Wait.
realize if we are missing something.
No, this is the first one. It's not n greater than n naught. It is some delta.
Delta, the first one is delta because x naught is fixed. So then something is wrong here.
Yeah, because see, we had. No. Yeah, this is n greater than. Sorry. It's true.
Yeah, the first one is in theory not needed because the third one is assuming the first one. But since we wrote it like this, let's keep it and see.
F of x, not f of x. Right. So when we, yeah, so when we add the second and third inequality.
Okay, add the second and third inequality. Let's add it and see it in front.
But so my last time before the video got over, my concern was that in the third inequality we have for all n greater than n naught, and the second inequality we have a band.
Yes,
So
that's right.
how do we deal with that? Like, so basically,
so you don't
should
use
we
this
also
thing. You just say that for that particular n naught this is happening. You don't need this. Just leave it. We are not using it so far. So
yeah, that's right. So basically we use that band, right? But we need to use that band.
yeah, we're just using that one fn. One fn we are using, which is close enough to f, epsilon close. Right. So sort of
Yeah, but
like
that band has to be there, right? Otherwise,
so that band is using fn. Fn, that one function is what is doing the thing, what is doing the trick, right? So yeah, and you will see that you maybe don't need the other functions in, and you will realize that that's later maybe. But let's see. But the point is that see we have x naught x, right? And then this is f, and maybe this is fn, the green one, right? We are trying to show that this height is sort of less, and we are trying to use that this height is less and this distance is less, and it sort of fits, right?
yeah. Mm-hmm.
Yeah.
Then you just do the triangle inequality,
Yeah.
and you get that. Yeah, you get that f of x minus fn of fn of x naught minus fx, that distance
Yes. Yeah.
minus f of x,
Hmm.
that distance
Can be
is
made.
actually we didn't need these two inequalities. This is like a very direct consequence. Fn of x naught minus f of x.
Is it a direct? So how? Yeah. How?
No,
No.
it intuitively feels so
Huh.
right now.
Intuitively. But this is subtle. This is a little subtle, right? Because you use the continuity of fn to show that fn at x can be approximated by fn at x naught. and then you use the
No,
convergence
the
of
thing is
Fn.
that, see, yeah, the continuity is there, but it's like that, right? That so for a certain error, you consider, so basically you consider a neighboring area of x naught. You're considering a neighboring area of x naught, and for that you are getting this inequality satisfied.
Mm-hmm.
And obviously f of x is very very near to fn of x. So for
Yes.
that band of f of x, it will obviously be near.
Uh, ye-
So you just consider that band of f of x.
no, but then you are assuming that f is continuous in your reasoning, sort of, and that
No,
is
why?
uh, because this is f at x, and you're sort of concluding its behavior using f at fn, using
Oh, yes,
sort of,
yes,
I
yes,
mean, yeah, I mean,
yes.
so from here it becomes, I think that it becomes absolutely clear that this result is true from this
Right.
discussion, but you have to just do one more step. But yes, you're right. I mean, it's sort of kind of, we realize that f has to be continuous, right?
Yeah,
Uh,
right.
uh,
Yeah, now we just have one more triangle inequality, and
yeah.
we maybe make the, yeah, we just have one more triangle inequality.
Yeah, so we just use this, yes, and then it's done. Just combine this, then it is done. Yeah, and then you choose the epsilons to be small enough, and right. And so then it's done. Let's just write done. Right. Yeah, it's not a hard result, but yeah, it's just that it's a good result. It's not so easy also.
Maybe, yeah.
Yeah.
Interesting result, yeah.
Yes. Yeah, and finally, I think so. Can you try to describe from here, how do you get that it has to be uniformly it has to be continuous, like intuitively, without going to the third inequality? I think at some point I had that intuition and then I lost it. So
Yeah, like I also, yeah, that's why I thought that this is, mm, see, the point is that fn of x and f of x are really close.
right.
And if that is there, then obviously the distance between, see, you draw a vertical line from fn of x naught, and it will obviously, yeah, so the thing is that it
Mhm.
it feels like it should intersect f of x. If it doesn't intersect f of x, so if it intersects f of x, then we know that it is continuous.
No, what intersects f of x?
See, what I said is, if you draw a vertical line through fn of x naught,
Through fn of x naught, yes.
now if it intersects f of x, then we can say
Huh.
that it is continuous, right?
Yes, that's
Because it will be defined at f of x naught.
it will be equal to f of x naught in that case.
Yeah, that's what. Yeah, that's what.
Then there is no problem. Yeah.
Then there is no problem. But if it does not, if it does not exist,
Uh-huh. Okay. Yeah. If it doesn't
if
intersect
it
or
does not
exist,
intersect at all,
huh? Right.
then
Still, its height cannot be too much, right? Because of this quadrilateral inequality. This is like a quadrilateral inequality instead of triangle inequality. That three sides of a quadrilateral is more than the sum of the three sides is more than the fourth side. Right. It is, you see, right? That is what it is, kind of applying it twice. It's a sort of like that. That we are saying that this distance cannot be too much because this distance is bounded by this distance plus this distance plus this distance. And these two are
yeah,
less because of the uniform convergence, and that is less because of the continuity of Fn. And so sum of three
right,
sides is less than the fourth side. That is,
right.
I think, yeah, once you draw that picture, I think, but yeah, all the same things we have done so far, but just a different way. Okay, yeah, this
Right.
is a good, yeah, it's a mouthful, but it's we've done it slowly, so it's fine. Yeah. Now maybe next, this is maybe a homework for you that you should think and tell us. Maybe give an example. Maybe you should present this next time if you can. Maybe you should try to think of some. Let me write the question, then it will be clear if it's easy or not. Example when this. I mean, some non-trivial example, not that 0, 0, so on. This converges to F not uniformly, but F is continuous. Okay, and obviously the FIs are continuous.
So basically you are saying that converse of this theorem is not true.
Yes. Yeah, the limit can be continuous in other cases. Yeah. Did we do any example? I think the examples we were sort of doing, it was uniformly. Yeah, we did examples where not uniform continuous implies not.
Actually, we didn't find any interesting example. Like most of our examples were like x raised to n or something like that, where at the end point it is discontinuous or it is totally uniform. There was nothing like continuous but not uniform, or even in discontinuous there was not any special example.
Yeah, so you should think. I mean, if you think, you will get some examples. Now that you have more intuition, that the resulting function is continuous, but its the convergence is not uniform. Okay.
Yeah,
you can think of this.
So there was a question which I was like attempting, not related to analysis.
Okay.
Related to, I don't know. It was like yeah. So I also solve a bit of +2 level problems, right, for the entrance next year. Because I have joined this class.
Yes.
For problem solving.
Which class is it?
You only suggested me, right? I joined Chinta because it is good actually. We only do problems.
Yes.
Yeah. Every day for an hour you do problems.
So yeah, they have some good instructors now, right? It's yeah,
actually they have got a good team, but I needed to do more problems, and that is what is happening right now.
Yeah, Chinta is nice. Yeah. So who was your instructor? I may know them. I don't know. If you know
I don't actually know their names because I just started right now. But maybe I'll get to know. But there is somebody called Arithro, and
okay, I don't know. Arithra or Arithro, I don't know. Yeah, I know one Arithra. I don't know. Is this from
Arithra
ISS?
is Aritra. I don't. But he is called Arithro.
Yes. He's from CMI.
Yeah, he's from CMI.
Yes, and I know him. Yeah, he's the. Yeah. I know him. Yeah. Yes, he was my junior. So yes. Right.
And I don't know about rest of them.
Okay. Yeah. Okay. So
there was this problem. So there is a tournament organized between family, and in that tournament, mother, son, and father play. So the tournament is like this, that they play a board game in which one is a winner and one is a loser, and they play till one person wins 2 games, not necessarily consecutive. The first time a person wins 2 games, he is declared the winner and the other 2 people are the losers. The father has the decision, the father has been given the power to decide if he he is given a choice whether to play in the first game or whether to sit outside. So what would you advise the father? So I did this, but I don't know if the solution is correct.
So you're saying that probabilistically, what is the better strategy?
Yeah, it's a USAMO problem. So it's
Ah.
basically given that what would you advise the father?
Yes, yeah. So I mean, what you can do is maybe. So what I would do is maybe if he goes first, then what is the probability? Yeah. So it's like, I mean, it's like a dice is rolled at random, and no.
No, what I did is that,
Uh-huh.
so first of all, what I did is that I considered that this is a kind of algorithm, right? Everything is a kind of algorithm. If first match occurs, this guy wins, then he plays next, then this guy loses. It's a kind of algorithm. So I first of all
Okay,
decided
what's
that,
the rule of playing? Like the winner stays, or what is it?
yeah, the winner stays and he plays with the person who is sitting outside.
Right.
It's like a round robin, not a round robin, but
Winners stay. Winners, yeah. Winners stay.
yeah, winner stays.
Uh-huh.
So that is the thing. And so basically, what I thought is I asked a very interesting question. I thought that what will be the maximal length of tournaments after which a winner has to be declared?
Mm-hmm.
So I got that answer to be 4.
Yeah, that should
And
be.
you can prove that because after
Yeah.
4 matches, so basically how I did it is that you denote
Yeah,
a
yeah,
win by
yeah.
1
I get it. Yeah. I know.
and
4-3, so
lost by
one has to
0.
come twice. Yes.
Yeah, by
I mean, if
pigeon hole.
someone
Yeah.
loses, the other has to win. So always there is a, yeah.
So basically, the 4 is the maximum number of tournaments. So now I
Yeah.
take the two
So you're
cases,
saying that you
case
just
1 and
write the
case 2.
list of wins, right? And there you find 2
Yeah,
wins
list
in.
of wins, and yeah. So I just concluded that if 4 is there,
Hmm.
these are the only cases.
Hmm.
And now I get that for